this one, right?
That's the one. Yep. You got an extra?
No, it's because I can't write. She likes to do my notes.
How much longer until your fingers heal?
I don't know. I took it off today to see if I can move it around, but I was writing earlier and it makes weird noises and makes sounds and feels weird.
Remind me again when you turn your back. Would you like this one?
She has mine, so she's like.
Yes. This is my last extra. Okay.
Thank you.
Sure thing. All right, let's do the warm-up. It says, 2 coworkers are sharing the driving on a trip from Los Angeles, California to Seattle, Washington. One of them drives at an average speed of 75 miles per hour, while the other prefers to drive at 50 miles per hour. They plan to cover at least 500 miles per day, and they don't want to spend more than 9 hours on the road each day. The slower driver prefers to spend less time behind the wheel than the faster counterpart. What is a graph that represents the possible number of hours each person can drive per day while meeting all the conditions? Okay. We're going to solve this together. Let's see here. I will give a bonus point. Let me see here. How can I don't want to give away too many answers. I'll figure it out. Okay, bonus point if someone can raise their hand and give me an inequality to represent the at least 500 miles per day part. Guessing is okay. I might even give you hints. So we're doing, it says they plan to cover at least 500 miles per day. Bonus point if you can come up with an inequality to represent that portion of the problem. Yes. No, just give it to me, however. So 75 what? Okay. Mhm. Good job. All right, so the first one we have, by the way, I'm using X for faster and Y for slower. So 75X plus 50Y is greater than or equal to 500, and that indicates that they're driving at least 500 miles per day. X is driving at 75 miles an hour. Y is driving at 50 miles an hour, on average. Markers keep disappearing.
Your markers are
It's disappearing because I'm behind. Alright, good job, Team 2. Alright, bonus point. Your Team 1. Bonus point if someone can raise their hand and give me an inequality that would represent driving no more than 9 hours. Yeah, so right here, it says they don't want to spend more than 9 hours on the road each day. Yes.
Wait, isn't it like something, and then it's like less than or equal to 9 hours?
It's something less than or equal to 9 hours, but what? Well, we already used the 500. Yes. Oh, wait, no, you got the last bonus point. So it is less than or equal to 9 hours. What is less than or equal to 9 hours? Okay. So we're basically translating the words into math that we can solve. So here it says they plan to cover at least 500 miles per day. This guy's driving at 75 miles an hour. So I'm going to multiply 75 times the number of hours. This guy's driving 50 miles an hour. So I'm going to multiply 50 times the number of hours for Y. add those together, it needs to be at least 500 miles an hour per day. 500 miles per day. You can't. I have to keep them separate.
But then when you multiply.
Well, I'm going to graph this. I'm not going to. You can't solve it. Yeah, it's fine. Yes. Less than. You said less than or greater than. I mean, it's less than. I got you. Yes, that is exactly right. So they don't want to spend more than 9 hours on the road each day. So x plus y must be less than or equal to 9. Does that make sense? Any questions on how we got x plus y is less than or equal to 9? Okay. And finally, it says the slower driver, that's y, prefers to spend less time driving than the faster driver, that's x. Bonus point if someone can give me an inequality to represent that. The slower driver driving less than the faster driver. Yes.
Wait, wouldn't it just be like the other way? For like the
It is less than, but what is less than what?
9.
So we already used the 9. What was it?
X and Y.
So what's less than what? Y is
less than
y is less than x.
Good job, Bruce.
Good job.
All right, so y is less than x because the slower driver wants to drive less than the faster driver. So here are our 3 inequalities. Does it make sense how we got them? This is the hardest part of word problems. Reading the problem and translating all these words into some kind of equation or inequality that we can actually work with. Once you get to here, it's just like any other problem. Do you guys feel like you can get these 2 into slope-intercept form? Yeah? All right, let's do this. You guys, how comfortable do you guys feel graphing these? Yes. Graphing all 3. I'm seeing 1 thumbs up and a lot of people looking uneasy. Okay, couple thumbs up. Okay, I guess I'm asking, do you guys want to graph them 1 at a time, or you guys want to graph all 3 and give me the graph? Yes.
I have a question. What does it say was less than?
The faster driver? There you go. Let's graph them 1 at a time. All right, so the first inequality, that's 75x plus 50y is greater than or equal to 500. On your whiteboards, please give me the graph. When you have it, hold up your board. Just the first one. We're doing them 1 at a time.
Wait, so are people doing skip rope today?
I'm sorry?
Are people doing skip rope today?
No, I just didn't get a chance to tear down the curtains. So I figured it's Halloween, I'll leave them up. If I have time after school today, I'll take them down, or maybe I'll wait till Monday. I don't know. I'm sorry? Oh, yeah, just the first one.
It shows
Yes.
Are you excited to watch it? I'm scared to see like badly wrong.
If it's badly wrong, you're learning. I made a hilarious mistake the other day. In the evenings, I'm taking a class on I'm trying to learn Japanese because my family's visiting Japan this summer and I want to learn some Japanese. I meant to say I eat dinner with my husband every night, but I forgot one of the articles, so what I actually said was I eat my husband every night.
Oh my gosh.
You know, I was like, it's Halloween.
the professor laughed.
And she said that was a wonderful mistake.
Wait, that's so cool that you're there.
I'm trying. I'm real slow with languages.
You have to do it till 100?
No. I have a y-intercept of 10. When you divide by 50?
Oh, like the graph can we go until 100?
Did you put it in slope-intercept form?
Oh my gosh.
Yeah, because after you divide by 50, 500 divided by 50 is 10.
Slope is 10, right? Yeah.
Oh, I'm getting a y-intercept of 10.
Yeah, y-intercept, and then slope is 2.
Wait, you want to learn 3 of them?
No, just the first one. Where is it shaded?
There.
Greater than.
Oh, wait, shoot.
Got it.
It's greater than.
Greater than below or
Above.
above?
You're just graphing the first one. Please note that it's greater than. That means above.
Yep.
But I can't. No, it's not getting itchy. It's getting tight over my head.
Once you get it right, please check in with your teammates. Make sure everyone's okay.
Just gonna have a wing cap on.
Honestly, I say that's what you have on.
So you guys know how to do it.
Where's it shaded?
Oh, that actually feels so much better.
Wait,
Wait, yo, is it like?
Wait, no, it's good.
Yep.
use your regular.
How's it coming, Team 3? You guys close? Yes. You're beautiful.
It's crazy.
She's getting her calculator.
Okay.
This was getting way.
Why do you need a calculator?
Where did Sunny go?
Yeah, where did Sunny go? She's been gone for a while.
I think she went to the bathroom.
Okay. Hopefully she's feeling okay. Alright, I'm going to give you guys one more minute and then we got to move on, okay?
I look like Gru if he was the Joker.
It's okay. It's fine.
Three over 2. Negative 3 over 2.
Where is it?
That's like free that I did.
Wait. Okay. Wait. So we might get this like really wrong. It's okay.
Oh my gosh, that's crazy.
Like,
It's okay? As you can see, the class is really focused right now.
how is B 100?
B is not 100, it's 10.
Wait, so long. If I hit the ball, no, it's okay.
The what?
If I hit a ball, I'm scared this little kid.
No, I don't agree to this.
Yeah. So excited. Wait, did she?
Wait, is this like look right?
Yes.
Okay.
So the first one.
Is this wrong?
Oh, yeah, those are the other ones. I see it. The first one is right. Absolutely right. You just need to graph it. You just need to graph it. Guys, graph it. Just graph it. You have like 20 seconds left. Give me a quick graph.
No, you remind me of that, but like the mouse. Yeah, it is. This is if you give a mouse a picture.
Wait,
I kind of want to. I don't have the GoPro.
Yeah,
I kind of want to scare Sunny, so I'm just gonna stay over here. Can I scare Sunny?
Huh? No.
like this, and then we shoot this.
Anyways,
That's sick.
and it's a comfy.
Okay, wait,
Wait, can I feel if it's soft?
It's not that soft.
Okay, so I'll try.
Is this the right word?
Yes, and then you shade where?
Here.
Above. All right, ladies. Congratulations. Everyone got it right. Here is the inequality in slope-intercept form. I'm not going to show the graph because my graph has all three of them. Are there any questions on the first inequality?
When you put all the three, then the other should form a shape.
It'll form like a kind of a triangular area. All right, do you guys feel ready to do the second one? Please graph the second inequality on the same graph. On the same graph. See if you can figure out where the shading is overlapped.
Oh my gosh, you know who I look like? Mr. Clean and he was
Yes.
Driving.
Yeah.
Someone tied a red balloon in like the
steward.
Oh, that's awesome.
and it was hanging as we're driving by. And
That's
I was like,
awesome. That's so cool.
that's scary though. I would
A few years ago, I had a better Pennywise costume, and I went to a Halloween party, and I carried a bouquet of red balloons, and I handed them out to people. No, this was a few years ago. Tonight, I got 2 kids. We're trick or treating, and then what? 6th and 7th grade, 11 and 12. 6th and 7th grade. 6, 7, yes. Word of the year. I don't even know who they are. They're some anime characters. They sent me Amazon links of what they wanted me to buy, and it was affordable, so I bought it. And they look great. I just don't know who they are.
Oh my gosh, you know what it looks like?
One of them is from Demon Slayer, and the other one is from some other anime that I don't know.
Wait, yeah, what did Carol look like?
Oh, I see it. Okay, so it'll actually be, because they crisscross, it'll end up with the shading in between.
Wait, what does the character look like?
I don't know. One of them's a girl for sure. The other one is a warrior, so, and with a wig. And you know how in anime their hair is like, so I don't know.
I believe this is what
Alright, ladies, I'm going to give you guys 1 more minute, and then we'll go over this.
Oh my god, what did I put it on last time?
Excuse me. Yeah. It's not going to be parallel. It's going to be kind of like this. They're just a little bit.
Oh, it's gonna take this. So graph.
Well, I mean, there's more graph over here. I just graphed that one area.
Yeah, it is. That's why I took it off.
So, if you extended these this way, the lines extend. I just graphed that one area because I wanted space. So, I just graphed this area here because I ran out of space. But you can graph the whole thing. Yes.
Is this right?
Yeah, but you need the other graph too.
Oh, okay.
I think you got it. All right, ladies. All right, ladies, please graph the last inequality. Please graph the last inequality. Notice the last inequality has a dotted line. So please graph the last inequality. You should have all 3 graphs on the same coordinate plane. When you have it, please hold up your board. You should have kind of a triangular region. The shading is not in the right place, but I'll give it to you.
Yeah.
So basically, it's y. So you're gonna just add. It's just the slope is gonna be 0 and you're gonna go up and up. Oh.
Yes, good job. Once you get it right, please check in with your teammates. Make sure everyone's okay. I'm going to give you guys 1 more minute. 3. You guys need to get a bonus point.
I'm not sure where the shading.
The shading is not in the right place, but I'll give it to you.
This is a dot.
The shading's not in the right place, but I'll give it to you. Team 4, you guys close? Yes. Okay. You could make it smaller or work on a separate sheet of paper. The shading's not in the right place, but I'll give it to you. All right, here is the answer. So you should have this region shaded. Any questions? Yeah, so it's here and it goes up 1 over 1, dotted line, and shaded below. Yeah. So this one is shaded above, this one shaded below, this one shaded below, and you can't have a negative number of miles or a negative number of hours, so I only graphed the first quadrant. All right, ladies, so it has been my experience in the past that substitution is a topic that most people have had prior experience with. So that's when you solve for x, you plug it in, and then you solve for y.
Can you just reteach it?
I am going to reteach it, but I wanted to just put out feelers. Have you guys, is this something you're familiar with? Yes. I'm hearing yeses and a few maybes. Okay. So I'm going to proceed as though you've seen it before, but if you need me to go a little slower, need more explanation, please stop me, let me know. All right? In the last block, it seemed like most of the class had seen this stuff before. All right, example number 1. Solve the system using substitution. So we have x plus y equals 6, and then y equals 3x. What you want to do is you want to isolate one of your variables. In this case, that's already done. We know that y equals 3x. Then you're going to take this and plug it in for y in the other equation. So I'm going to rewrite this equation, but instead of y, I'm going to write the thing that y equals. In this case, that's 3x. When I do that, so here's x plus y equals 6. I'm going to replace y with 3x, so now I have x plus 3x equals 6. The goal in doing this is to get rid of one of the variables. Because if there's 2 variables, we can't solve it. We need to get rid of one of them so that we can solve the variables. By doing this, I've replaced y with 3x. Now there's no y. Now I've got like terms. X plus 3x is 4x. In order to isolate x, I'm going to divide both sides by 4. X equals 3 over 2. You guys good so far?
Yes.
Everyone okay? Any questions so far? Okay. Now that I have a number, a numerical value for x, I can take this and I can plug it into either of these equations and solve for y. It doesn't matter which one. I'm going to choose to plug it in for this one. So I've got y equals 3x. Instead of x, I'm going to write 3 over 2. 3 times 3 over 2 is 9 over 2. You guys are allowed to use calculators on this test, but hopefully all of you know that 3 times 3 is 9. Yes. Okay? So the answer here would be 3 over 2, comma, 9 over 2. And what that means is that if you were to graph these, those 2 lines would intersect at the point 3 over 2, 9 over 2. Any questions? Do you guys? Yes.
So you can technically plug it into either.
You can plug either one. Yeah, it's a little easier with that one.
Because it's easier, right?
Yeah. Yeah, pick the easier one, if there is an easier one. Do you guys feel like you could solve a similar one? Or at least well enough to give it a try? So let's give it a go. I think you guys got this. Does anyone need a little bit more time to copy this down? Okay. All right, here is the practice. It says, solve the system using substitution. We're given x plus 2 equals y, 3x plus 4y equals 5. Notice y is already solved for, once again. That won't always be the case. Ladies, shh. That won't always be the case. Sometimes you will have to isolate one of your variables and then plug it in. But in this case, they're being nice. So, you're going to rewrite this equation, but instead of y, you're going to write x plus 2, because y equals x plus 2. So I'm replacing y with x plus 2. Can you guys take it from here? Do you guys just want to solve for x first? Or you guys want to solve the whole way? The whole way? Okay. Go ahead and solve the whole way. When you have your answer, hold up your board. You know what? I'm going to take it back. You get a fraction answer here, so let's just solve for x to start. When you have x, hold up your board, I'll give you a point, and then we'll all solve for y together. So you're just solving for x. That's it. Just x. When you distribute the 4. So what does x equal?
This is crazy.
Yes. Yes. 1 and 4, you guys are awesome. Great job. 2 and 3, you guys close? I'll give you guys 1 more minute. Did you break my candle?
I'll fix it. I know how to fix things.
It lasted 5 years, and then Sunny came. Yes. You guys are awesome. Good job.
Oh, I see.
Team 2, you guys close? Yes. You guys are all solving this, right? You're not just letting her solve everything. I just noticed that she's answered every time so far. Maybe someone else do the white one. All right. Negative 3 over 7 is correct. Please use that to solve for y.
Are you gonna get a fraction for this one too?
Yes, it is.
Good job.
Are the batteries in the right way?
Okay, wait, which way are these supposed to go? I know there's like one has to be up and one has to be down, right?
Catalina, are you going to have one?
Wow. Get it away from me. I think she got it. Gracie,
Okay.
did you already get it?
Do you guys have the answer? I'm waiting for you guys' answer. Teams 2, 3, and 4. I'm just waiting for your answer. I'm waiting for y. We're solving for y.
And put back up so just more for But it smells like a muka. Oh shoot, I did this one. It's okay, we all make mistakes. Pointing your eyes. Oh wait, are those fake?
Isn't it with like to find y, it's an m.
No, you're just plugging in 3 over 7 for x. Negative 3 over 7 for x. I'd recommend plugging it into the first equation. It's easier. Excuse me. Do I have any cough drops? Cough drops. Yeah. I like honey. Here. Here. I like these. I like honey.
Oh my gosh, guys, I'm so like, I wrote Wait, Miss Alma, so we just solve it?
You're just solving for y. You're replacing x with negative 3 over 7. So there's no more x.
Oh.
Alright, ladies, I'm going to give you guys 1 more minute and then we'll go over this.
Why? My parents said yes, my dad said no.
Is there a fraction?
Can you solve this problem first?
Yes, I did. It's actually negative 7 over 3.
No.
Girl, this is not the answer.
No, Lucy already saw it. You said it was so basically, you're gonna plug in the negative 3 over 7 for the x with 3. Negative 3 over 7 plus 2.
No, sorry. Your denominator's right. Your numerator's incorrect.
I did the second one.
Do we get it this way?
It's a fraction.
Sorry.
Alright, last call for answers. Anybody else? Alright, here is the answer. Okay, ladies, please give me your attention. This is a lot easier than some teams were making it out to be. You know that x plus 2 equals y. You know that x is negative 3 over 7. This, you can put into your calculator.
That's what I was doing.
You have negative 3 over 7 plus 2 equals. Math, enter, enter. Done. I'll do it again. Negative 3 over 7 plus 2 equals. Math, enter, enter.
Whenever I hit like the divide sign to get the slash, it would always just enters it.
It's just divide. You can subtract the fractions by hand, but you don't have to. Okay? In fact, I recommend if you're allowed a calculator, use the calculator. All right, ladies, are there any questions on this one? Okay. So, now we've learned how to solve a linear system using graphing. We've learned how to solve it using substitution. I'm now going to show you guys my favorite way to solve linear systems. Does anyone need a little more time to copy? Ladies, shh. Anyone need a little more time to copy this down? Okay. So example number 2. We have 3x plus 5y equals 7. 6x minus 5y equals negative 16. As I said before, this is actually my favorite way of solving linear systems. You'll notice moving forward anytime there's a situation where you could solve this using substitution or elimination or graphing or whatever. I have a tendency to prefer elimination. You guys can use whatever method you want. Ladies, shh. I just want to make sure you know how to do all 3. Okay, so we are given these 2 equations. Notice that these coefficients are the same. We've got a 5 and we've got a negative 5. You can add these vertically to eliminate a variable. 3x plus 6x is 9x. 5y plus negative 5y, 0. 7 plus negative 16 is negative 9. If you do this right, one of your variables will be eliminated, hence the name elimination. If after adding or subtracting, you end up with an x and a y down here, or whatever your two letters are, something went wrong, okay? Once you add or subtract vertically, one of your variables should go away, if you did it right. Excuse me. All right, so from here, I'm going to divide both sides by 9. X equals negative 1. Did that make sense? Okay, so as you can see, much faster, right? Now that I have a number, a numerical value for x, I can plug that into either equation. Doesn't matter which one. I'm just going to use the first one. So we have 3x plus 5y equals 7. 3 times negative 1 plus 5y equals 7. 3 times negative 1 is negative 3. Negative 3 plus 5y equals 7. Add 3 to both sides. 5y equals 10. Divide by 5. Y equals 2. So my ordered pair, negative 1, 2. So if I was to graph these, this is where they would intersect. Are there any questions? Do you guys feel like you could solve one like this? Yeah? Okay. I'm going to get you guys started, okay? Does anyone need a little more time to copy this down? Okay. All right, so solve the system using elimination. So we are given x minus y equals negative 2, 3x minus y equals 2. Now, you might notice if we were to add vertically, we would get 4x minus 2y equals 0. 4x minus 2y equals 0. We have an x and a y still, so it didn't work. So we're not going to want to add in this case. But if we subtract, what is negative y minus negative y? Well, minus negative becomes a positive. No. What's negative 1 minus negative 1?
Can you say it one more time?
Negative 1 minus negative 1. 0.
Wait, how is negative 1 minus negative 1 0? What is negative 2?
No.
Yeah, but that's adding.
That's negative 1 minus negative 1. These become positive. Right?
So how would it be positive?
Anytime you have minus negative, it becomes positive.
1 plus 1 is 2.
1 plus 1 is 2. Yes. Good job. And negative 1 minus 1 is negative 2. Negative 1 minus negative 1 is 0. Just like,
parentheses?
no, because a minus negative becomes positive. What's negative 1 plus 1? 0.
But wouldn't it? Okay.
Similarly, negative y minus negative y equals 0. So, okay, a good rule of thumb, if you kind of have trouble with positives and negatives, when you're doing elimination, if your coefficients are the same, if the sign is different, like one's positive, one's negative, add. If the signs are the same, like they're both positive or they're both negative, subtract. Does that make sense? Yeah. That's a good hint to put on your index card. All right. So, if you subtract vertically, tell me, bonus point, what is x minus 3x? Someone raise your hand and tell me. X minus 3x, yes?
Negative 2x. Negative 2x? You got first.
Negative 2x. Good job.
We give you the answer.
And another bonus point. What is negative y minus negative y? Yes. Yay! And a third bonus point. What is negative 2 minus 2? All right. Did everyone answer? Wait, who got the last one?
We did.
And I give you the point. Okay, perfect. Okay, so here we go. So now we have negative 2x equals negative 4. Can you guys take it from here? Please solve for x and y. Give me your answer as an ordered pair. Please give me your answer as an ordered pair. You just had x. We'll solve for x first, then solve for y.
Is that 2? Oh, wait.
Just put it on your whiteboard and hold it up. Okay. Ordered pair. Give me x and y. Huh? You can. Yes. Good job. Can you keep your head up, please? Okay. Once you get it right, please check with your teammates. Make sure everyone's okay. Yeah. No, sorry. Your X is correct. Y is not 8.
Do I put whatever X is into the
Yes.
and I put it in
Whichever one. Your X was correct the first time.
Okay, try that. This is just try.
Nope.
Oh no,
Yeah.
yeah, it's
We're going to give you guys one more minute.
right. Get it right? I actually know we didn't get it right.
Good job.
What do you put? So then Y equals 0.
Y does not equal 0.
So X equals 0, Y equals 2.
X equals 2.
Wait, can you
Well, I'm going to go over it in 30 seconds.
wait,
Plug in 2 for X and solve for Y.
oh, I saw it's for X.
Plug in 2 for X and solve for Y. Yep. All right, everyone got it? Here is the answer. Yes, we get out at 11:10 in 12 minutes.
And then he said he'll break his arm.
Yes. Any questions on this? I'll leave it up there for a bit. No, I did before. Yeah, so, yes. Usually after 2 or 3 teams answer, I'll let everyone know, hey, there's one more minute. And then I set a timer. All right. Does anyone need more time? You got it. Yep. Just going through cough drops like crazy. That would be a good idea. But this will get me through today. All right, ladies, please turn the page. On the back it says, example number 3, determine the number of solutions to each system using either substitution or elimination. Okay, ladies, Here is my recommendation for these. I don't recommend you solve them all the way. What you're going to want to do for each one is start solving it, and if it's clear that you're going to get a number for x or for y, then that's one solution. Ladies, shh, that's one solution. If it's clear that your x and y are going to get eliminated, like both of them are going to disappear, what happens if you get a false statement? What's the answer? No solution. So if you get 0 equals 5 or negative 18 equals positive 18, no solution. What happens if you get a true statement?
It's a solution.
Infinitely many.
Wait.
So if you get 0 equals 0 or 5 equals 5, infinitely many solutions. Do you guys understand what's going on here?
I think so.
Okay, so again, I don't expect you to solve this all the way out. There's not enough space. I expect you to start solving it, and when you hit the point where it's clear that you're going to get a solution or you're not going to get a solution, stop, because all they want to know is there one solution, is there no solution, or is there infinitely many? So those are the three possibilities. One solution, no solution, or infinitely many solutions. Okay? Now, because there's only three possibilities, your team only has one chance to answer. Okay, so whenever you have your answer, make sure everyone on your at your table agrees before you hold up your board. And let's just do number 1. When you have it, hold up your board. You're just telling me one solution, no solution, or infinitely many. That's it. You're not solving it all the way. Just tell me one solution, no solution, or infinitely many. You're only going to give me one of these? Just number 1. Just do number 1. That's it. Just tell me number 1. But again, you only have one chance to answer, so make sure everyone at your table agrees before you hold up your board. And please don't leave it all for one person to do. Just saying. That's kind of messed up. So you guys are just giving me one solution, no solution, or infinitely many. Just write it on your whiteboard, hold it up.
You can't help us.
What do you need help with?
Oh, with like
You don't need to actually solve it. No, you just need to tell me, is there one solution, no solution, or infinitely many? So once you get to a point where it's like, I'm going to get a solution, or I'm not going to get a solution, you're done. I'm going to give you guys one more minute. Again, you should not be solving it all the way. Okay? I'll tell you in 40 seconds. You guys have about 30 seconds. Give me an answer. Just put it on a board. Hold it up when you have it, okay? Okay? What does it say? It just says solution. It's either one solution, no solution, or infinitely many solutions. Okay, team 2, you have an answer? Okay. Everybody got it. Good job. All right, ladies. So this is what I did. I prefer elimination, so I multiplied my first equation by 2. Ladies, I got 4x plus 6y equals 12. And then I subtracted. 4x minus 4x is 0. Negative y minus 6y is negative 7y. Negative 7y equals negative 19. I don't need to solve any further. I can tell that when I divide by negative 7, I'm going to get y equals something. So that means there's one solution. I'm done. Any questions on this one? All right. Can you guys solve the next 3 like this? Okay. Please solve the next 3. I'm going to give you guys 3 minutes. Hold up your board when you have them all. Again, you're solving the next 3. I'm giving you 3 minutes. So when you hold up your board, please make sure you have 2, 3, 4. You're doing 2, 3, and 4, yes. I'm giving you 3 minutes to do all 3. Don't solve them all the way. You should only be doing a couple of steps. If you're worried, you can even divvy it up. Maybe like each person on your team does one.
Wait, no, I'm not. Do the score. That's weird. I got one. I'm doing 3 right now. I'm doing 2. Sorry. Wait, are you doing 2? Are you doing 2? I'm doing 2 right now.
Okay.
I'm doing 3.
Okay, can I see it one more time? Okay. Thank you. I'll tell you in 1 minute and 30 seconds. All right, ladies, there's about a little over 1 minute. Any other answers?
Wait, we don't have time left?
So I said you had 3 minutes to solve all 3 problems. I suggested that maybe you divvy it up.
Okay, well, let me know when you guys want to see that.
We already did 1. You're just doing 2, 3, and 4. Make sure you number them 2, 3, and 4 when you hold up your board. Anyone have any answers for me? If you don't finish all of them, that's okay. Just give me what you have. Okay. Teams 1 and 2. Anybody? Got 20 seconds left. I'm sorry that I can't give you more time. Okay. Can I see team 2? Team 2. You're solving 2, 3, and 4. Which one is that for? Is that number 2? It's correct. All right. So clearly this one was a struggle. Here's the answer. So this one, again, I used elimination. I multiplied by 10. I was getting 1 solution for x, so 1 solution. For 3 and 4, this one I multiplied by 2 to get rid of the fraction. This gave me 2y equals 3x minus 10. I subtracted 3x. And when I lined these up, I realized I was going to get 0 on this side and something that wasn't 0 on the other side. So that's no solution. This one, oh, hold on. Oh, okay. 2 4 simplifies to 1/2. 4 6 simplifies to 2/3. So this is really the same equation as this one. All right, you guys did a great job today. Have a happy Halloween. Be safe out there.